Math 111 students. I'm here in a new environment recording this video. We are in chapter 7 now, 7.1, and my mom broke her femur, so I'm working from her house today, which is a very nice sunny house. But anyway, may hear some Law and Order or Dateline in the background. Hope it's not distracting. All right, we're just going to jump right on in to 7.1, and we are doing applications of right triangles, solving applications of right triangles. And particularly today, we're going to solve right triangles, some applied problems. And really the only two things we really need today is the Pythagorean theorem, c squared equals a squared plus b squared, because all of these are going to be right triangles. And remember that all three angles of a triangle add up to be 180 degrees. So if one angle is 90, then the other two angles have to add up to be 90. Okay. All right. And with those things, then we can start solving these. And what we mean when we say solving a right triangle, we mean that we're going to find all of the angle measures and all of the side lengths. All right. So we know in this one that the side B is 4. That's the side opposite of angle B. And angle A is 35 degrees. Well, if angle A is 35 degrees, and you immediately know B is just going to be 90 minus 35. So B is 55, okay? So we already know that B is 55 degrees, okay? Now, A and C, we know B is 4, and we know angle B is 55. You can use the tangent or the cotangent or the cosine or the sine, really. Let's see, sine of B would be the opposite over the, okay, you have a lot of options. They use tangent of 35 degrees. That's the A value. So the tangent of the 35 would be the opposite side, the A, over the adjacent side, the B. And so that gave them that the tangent of 35 degrees would be A over 4. Well, then it's real easy to find A. A is just 4 times the tangent of 35. Make sure you're in degree mode. Okay, I am in radian mode, so I'm going to go over here on my calculator and make sure I'm in degree mode. And then I just put in 4 times the tangent of 35 degrees, and I got 2.8, rounded to the nearest hundredth, 2.80. They use cosine of 35 degrees. Cosine of 35 would be the adjacent 4 over the hypotenuse C, and they use that to find C. So cosine 35 is 4 over C. Then you got to do a little work to solve that one here. C would be 4 divided by cosine 35, and that would be 4.88. 4.88. Okay. All right, now what if we know that A is 4 and B is 2, and we need to find everything else? I'm going to draw this guy out real quick. Okay. So we've got an angle here, right? 90 degrees. Okay. This is A, and this is B. So this is little b, that's little a, and our hypotenuse is C. And we said on ours that A was 4 and B was 2. So A is 4 and B is 2. A equals 4 and B equals 2. Okay, well, if we know A and B, we can pretty easily find C. A squared plus B squared equals C squared. Okay, so 4 squared is 16, plus 2 squared is 4 equals C squared. 20 equals C squared. Take the square root of both sides. Hope you're getting comfortable with this. That would be C equals the square root of 2 times 2 times 5. If you're using the jailbreak out method, a pair of 2's can break out. Only one survives on the outside. You have 2 root 5 is your hypotenuse. Our hypotenuse is 2 root 5. All right, you can use pretty much whatever you want now to find these guys. Let's use sine. The sine of A is going to be the opposite. Oh, let's do tangent because that'll be a little bit, it doesn't. Sine of A is going to be the opposite, the 4 over the hypotenuse, the 2 root 5. Okay, so the inverse sine of 4 over 2 root 5 is going to be whatever angle A is. All right. You might recognize that 2 will go in the 4 2 times. So I can just really just go inverse sine of 2 divided by root 5. All right. Inverse sine. Let me clear off everybody. Second sine. That's the inverse sine. Can you see that clear enough? You need to get it in the light. Inverse sine. And we're doing 2 divided by the root of 5, root of 5, and I'm closing my parentheses, and I got to close another parentheses, and I get an angle of 63.4. All right, so angle A will be 63.4. Super easy to find angle B then. 90 minus 63.4. So that's going to be 26.6. Okay. So angle B is 26.6. Angle A is 63.4. Hypotenuse was 2 root 5. Sorry for all the shaking. I'm using kind of less than sturdy coffee tables. All right. So now let's do some applied problems here. All right. A straight trail leads from the Alpine Hotel, elevation 8,000 feet, to a scenic overlook, which is 11,000 feet. So kind of look at if you start at the base of your hotel, you're at 8,000 feet. But once you get to the elevation overlook, you have climbed 3,100 feet. So now you're at an elevation of 11,100 feet. And the length of the trail, which in this triangle would be the hypotenuse, is going to be 14,100 feet. And you want to find the angle of inclination. You want to find angle B. All right, well, the angle B, the angle of incline up, will be, the opposite side of B, 3,100. The hypotenuse of B, 14,100. So let's use sine. The sine of B will be 3,100 over 14,100. So let's use the inverse sine. The inverse sine of B, the inverse sine of 3,100 over 14,100. Okay. I'm going to do the inverse sine. Second inverse. What do we say? 3,100 feet was the elevation divided by the 14,100 feet, which was so this was the opposite side of that angle divided by the hypotenuse. And we get an angle of about 12.7 degrees elevation. Okay, about 12.7 degrees elevation. All right, not tough, not even terrible. All right, a lighthouse stands 100 feet high on a hill that's 300 feet high. Okay, so its beam of light is 400 feet above sea level. So it's up on a hill, and then on top of the hill is lighthouse. So the lighthouse is about 400 feet high. A brochure says that the light can be seen on the horizon about 26 miles apart. And they want us to verify the accuracy of this statement. And the way we're going to do it is use the rotation of the Earth. So the radius of the Earth is 3,960 miles. So if we drew a right triangle as pictured, and the side, let's see, you've got a length of 3,900, then the length of the hypotenuse here is going to be 3,960 plus the extra 400 feet. And then what we want to know is if S would equal 26 miles. Well, you can really just use the Pythagorean theorem. Let's just use the Pythagorean theorem. Does 39,060 plus 400 feet? How much 400 feet? What is that? What part of a mile is that? All right, well, 400 feet, remember 1 mile is 5,280. We need this guy a little bit brighter, don't we? Let's see if we can get this guy a little bit brighter. Okay. All right, so we have how many feet? We were 400 feet above sea level, and 1 mile is 5,000, oops, not 25, 5,280. So that 400 feet is about 0.08 of a mile, okay? So then the question is, does the Pythagorean work theorem fit here? All right, so does 3,960 squared, that was the length of one side, plus the 26 miles squared, will that equal the hypotenuse? All right, so that's what we get for that one. The hypotenuse was 3,960.08. Okay, so does the one side squared plus the other side squared equal the hypotenuse squared? Ah, boy, that's really close. Yeah, pretty doggone close. All right, so I'm saying we've got maybe not totally off. Now they did a lot more. What not doing that? Now we did not consider nautical miles versus stationary miles. But let's see, what was their conclusion? No, sure. They think the brochure overstated the distance. And I don't think the brochure did personally, but I'm reasoning through it a different way than they do. All right, how about navigation? Navigation and surveying, are you familiar with navigation? The direction or bearing from point O, which would be kind of at the origin if you use your northwest, east, and south. Point O to point P equals the acute angle theta between the ray OP and the vertical line through O. All right, so what are we saying? All right, look here at OP1. If I'm going to describe the bearing, the direction or the bearing from O to P1, all right, I'm going to use the acute angle. So I'm going to use the smaller of the two angles. I'm going to use the 30, not the 60 that would go down the east. I'm going to go do the 30 that goes toward the north, and this would be 30 degrees northeast. North 30 degrees east because you're closer to the north. Okay. P3, you're always going to use the north-south line as your point. All right, so P3, we're going to go north, the angle that's width closest to the north, so 70 degrees, and west because you are in the northwest quadrant. P2, we're in the southwest quadrant, so this will be south. 50 degrees is the angle down to the south pole there, southwest. All right. All right, so how about, what is the bearing from O to P4 here, down here? This is going to be in the southeast quadrant, so this is south 20 degrees east. South 20 degrees east. All right, so a Boeing aircraft takes off from Nashville International Airport, I've been there, on runway 2 left, which has the bearing north 20 degrees east. After flying for 1 mile in that direction, the pilot of the aircraft requests permission to turn 90 degrees and head toward the northwest. After the plane goes 2 miles, what bearing should the control tower now use to locate the aircraft? So much application in real life of this thing. All right, so they took off on runway left, going north 20 degrees east. They went 1 mile, turned 90 degrees right, went 2 miles. Now they're at some other point, and we are supposed to figure out their new bearings. Okay. What we need to do is figure out this angle theta and then subtract 20 degrees off of that. All right. This angle theta, I know 1, I know 2, I know I could do the tangent. The tangent of this angle theta is going to be the opposite over the adjacent. So the inverse tangent of theta is the inverse tangent of 2 would be our angle. Inverse tangent of 2. And we are in degree mode. So I'm going to do the inverse tangent of 2. And I get an angle of 63.43, but I need to take off 20 degrees. Okay. So we're going to take off 20 degrees here. And we will get an angle, this theta, this part that's in the northwest quadrant is only 43 degrees. And so it'll be north 43 degrees west. North 40 degrees, north 43.4 degrees west. All right. Keyword today in 7.1 is the sperm whale. The sperm whale. And nobody should be asking how I got that name. I don't even know. Don't want to know. Okay. Hope you're having a good day, and we will see you later. Bye.